I will be demonstrating how what is join in SQL. So we will be discussing left join, right join, inner join, and full outer join. And we will start from the ERD. Then we will move to the database and we'll start writing SQL. And we'll dig more into the details in this video. So let us first understand the entity relationship. Over here, you can see there are tables like class, teacher, and students. A student and teachers, a class can have multiple students. So we can see there is 1 to n relationship between a class to student. Similarly, a class can have only one class teacher. So you can see there is 1 to 1 relationship between a class and class teacher ID. But in a normal scenario, a class can have multiple class teachers, as well as a teacher can teach in multiple classes. So here we can see that they have many to many relationship, and in case of many to many relationship, we have to create a pivot table, and in that pivot table we need to store the class ID, which is the primary key of this class table, along with the teacher ID, which is the primary key of this teachers table. And once this is done, the whole diagrams look like this. And this is a very basic diagram, and here we will try to use different kind of joining methods to get the whole values of these tables collectively. Let us now proceed with the database. So here I have already created the database with some sample data. Let me close all the stuff. So I can go, there is class, there is class teacher, there is student, and there is teacher. So if I can go and let me go to classes. So if I click on this, I can see there the name of the classes are EE, CSE, EIE, IT, and ME, and we have a class teacher IDs. Similarly, if I go to teacher, I can see all the class teachers in this table. So they are already pre-filled, and I can go to students table. I will be able to see the students. And similarly, this is the pivot table where we have the class teacher ID, class ID and teacher ID. And the class table, I have the foreign key of teacher table, and this is class teacher ID, which represents the class teacher of a particular class. So let us first understand inner join. So let us first bring up the diagram. So we will first start with inner join, where we will try to connect this student with class, and we will connect them in a way where the student data and class data will come up together. And in inner join means, if we go by the definition, then we will see only the common data. So this means if some values from the left hand side or the right hand side are not matching, they will be ignored. So let us begin. Let us write the query. Select star from, so student table, which is student. Let me try to run it. I'll see it's running fine. Then I will write join on class with, join class on class star ID, which equals to student dot class ID. Now, and if I run this, I will be able to see 3 data. So if I run only this query, I see 4 data, 1, 2, 3, 4. But if I run both of this, I will see only 3 data. So let me just open this in new tab. So the student in this, the class ID is 6, and if I go to the class table, I will see that there is no class with the ID 6. So that value is ignored, and we would now only have the common intersection values. Okay, so instead of yeah, so the common values. So if we want to connect class with class teacher, what we can do is like we can again join class, not yeah, class dot join, sorry, teacher on class dot class teacher id equals to mm, teacher id foreign key. If I run it, I will have the teacher details too. So right now it's written in a way where we can see data like first name. So this creates an ambiguity, and in order to solve that, what we can do, like we can structure our select in a proper way, and this will give a data in a better format. So we can write student dot first name as student first name, comma, student dot, sorry, typo, last name as student underscore last name, and so on. We can create the whole list. Marks can be marks, then address can be address, then we can have the class dot name as class name, then we can have teacher dot first name as teacher first name, then we can have teacher dot last name as teacher dot last name, and so on. So right now I'm sticking to this for the sake of this video. Let me try to run this. So I will now use ambiguity. Okay, again the ambiguity, because we have in student we have address, and in all, I think in teacher also we have address. So we have to define. So let me define it properly, like student dot address as student address, and in similar fashion I can do uh, teacher dot address as teacher underscore address, and if I now run it, I will get the values. You see, all predefined in a well manner. I can also write as student dot id as id. So this will give me the primary key of the student. Yep, this is working fine. Yep, so this is working fine. So we have done a inner join with two separate tables. So a join can have multiple tables together. I can run on various operations on the select. One such operation is like if I need the full name of the student, so all I have to do, I have to run a con command with student dot first name, comma, student dot last name. Then we have to define as student, sorry, typo, full name, comma, and let me run it now. So if I run it, does not contain, let me check the error code. So concat, let me try it. Yes, so, but I can see that this first name and last name are combined together without any space. So I can add whatever I want to over here in between, like this spacer, and the spacer will create additional space. So instead of, like, if I have to fetch in, I have to put full name everywhere, and then I'm fetching the values, and then I am concatenating it within my code. So rather than that, to make it faster and better and cleaner, we can write the SQL itself. And once it's written in SQL, we can use it throughout our codes. So this is so far inner joining. So let me remove, yeah. So instead of this, let me write inner join, let me write left join. Now try to run it. Let me see. Nothing changed. Okay, let me write another one. Let me copy it out. Let me open this query box, and instead of our values from here, let me put the good old star, so we don't get into something where we don't have the values. So if I do this, this does inner join, so only the common values. So if I do left join, so here the student is our left table. So everything from student, and if something is not there from the class which is on the right hand side, then it will be presented as null. So let me quickly run it. So you see null. So everything from class we are getting null. And so this is our join. So similar fashion, if I go to right join, so if I go and write right join, say for example, so everything from the now class is the right hand side, and we will get everything from class. And if I don't have any student for that class, that will be ignored, and that will come as a null. So let me run it. You see, so we don't have any student data for these classes, and that's why we can see null. So, and for full join, like full join will be like for the values on which right hand side doesn't have values, for left hand side values on which right hand side don't have values, it will be null, and vice versa. So we will have everything from the tables, and but null will be placed where we have no matching values. Let me just do it for you real quick. This is full join, and let me just write out full join, and there is no condition to it. It combines to everything, and let me just run it. You see, permutation combination of everything. Okay, full join and full. You can have permutation, I think. No, full join only. So this is full join. This is so far. So we crisscrossed everything from both the tables, from students to classes. Now this is so far. So let us go back to the query which we had created over here. So this is a big query and a beautiful query which sorts a lot of data for us. Now we don't want to write this query again and again. So there is a very beautiful thing in MySQL or in SQL servers are these views. And if we know how to use these views, then a lot of work becomes very easy and code becomes a very streamlined. And it's pretty simple too. All we can do, we can write a create view, and then we have to just copy the code which we have created, and then instead of new view we can write the name as uh, student details view or something like that. Student underscore details, and then we can write our query, and then all we have to do is to apply it. So once we apply this thing, we have a view, and this is the virtual table created out of the definitions which we have put in over here. And if I write this, you'll see it is getting treated as a table. And if I need to find say for example student with higher marks, so I can write uh, order by marks DSC. Then I can run it and it sorts everything based on marks. So this is one beautiful thing which we can use, where we can use MySQL views, so we don't have to repeat our uh, complex SQL query again and again. So that's it for this video. We'll continue next video, and please like, share and subscribe this video so that this helps us a lot. Thank you.